Highlight regression, click OK. So this data is called fire. So we have, like thousands of dollars in damage, and how many miles you are away from the fire station. So what might our hypothesis be?
Closer to the fire station.
Less damage.
Less damage you receive. So we can use this regression to test it. So I can highlight the y variable. Let's add the label. And highlight the x variable, miles. Damage depends on how long it takes the fire to be put out. Pretty intuitive. So damages are dependent, miles are independent variable. Let's add our labels. That checkbox simply tells us the first row contains the names. Let's give it an output range. Let's just stick it right here. So we see that miles alone explains 92% of the variation in the fire damage. It's a really good predictor for whether your house will survive.
That damage is the cost value or the percentage? Because
Should be a cost value like thousands of dollars.
if there were more expensive building structures, whatever, closer to the fire station, that could throw your numbers off.
It could give you bias, right? This is just right. There could be the same issue of we don't have a lot of variables. We don't know whether it's a more expensive house. So our coefficient on miles is 4.9. So for every mile, for every extra mile you are away from the fire station, if your house catches on fire, you can expect about $5,000 more damage. Because it takes a little bit longer for them to get there.
Right next to the fire station.
So what do you think about the home values when there's a fire station right next door? A little higher. And the p-value is really, really small. Like super, super small. So it's highly significant.
The R2 is what we're looking for on or the R square?
The R square says this variable alone explains 92% of the variation in the fire damage. Which is good if you're looking for a simple model to explain damage to someone.